Back to the Night Porter app we made in the first module. We'd added one piece of behavior, a single line of code that changes the background when a button is clicked. But this one line gives us a lot to talk about, and I want to cover two things about it in the next couple of minutes. The word view and these letters UI. In iOS, you'll often see the letters UI as a prefix. It's not the only prefix you're going to see, but UI is the most common here. The reason is that when Apple wrote the developer libraries for iOS, they created multiple classes we can use for iOS-specific user interface behavior, and not just controls like buttons, sliders, and text fields. Sure, we get those, but also bigger concepts, classes that represent an iOS application, or an image, or a color, or a font, or that even contain functionality for a touch or a gesture. And these were all given the prefix UI. So we have UI button, UI label, UI application, UI color, dozens more of them, and all of this put together and wrapped up in a framework that Apple calls UI Kit. And this line at the start of our file is what links our Swift to that framework and makes everything available in it. UIKit is the core framework for iOS development. As we build more complex apps, we may import other frameworks too, but we'll always need this one. And that includes the class called UI color here, and that has a method called dark gray color that returns a new UI color object with specific settings. But here's the question: how would you know this method exists? Well, as you start to write code and you find out that certain classes exist, if you have the inspectors open on the right, one of the useful ones is the Quick Help Inspector, the one that looks like a question mark. And as you click around inside a code file, like clicking on the class name UI color, you'll get more information about that. If it's something that Xcode can provide help for, it will. So I can read the basics. This is a UI color object that represents color and sometimes opacity. I can take a look. I can even find that there's a UI color class reference that I can click through and get the larger amounts of information straight from within Xcode. If I click the actual method itself, just this dark gray color, it'll tell me this will return a color object whose grayscale is 1/3 and alpha value is 1.0. Okay, this is a way that we can start to drill down and get more information. Now, if I don't have that panel open, another way to get to the same information is that when I'm in a code file, if I hold down the Option key, it'll turn into a question mark when there's something clickable that I can mouse over. So I can hit it and click on UI color. I'll get the same pop-up information I got in the Quick Help window, or I can hold down Option and click the method itself and get that same information that we saw a moment ago. As this is a fundamentals course, we'll only be able to touch upon a few common classes. So this is one way that you can start to drill deeper. So we're using this UI color object to set a property, and it's the background color property of something called view. And that is a word we need to talk about. In iOS, view is a word worth exploring. You'll see it a lot, and it has a couple of different meanings. Because when we talk about a view in iOS, we can be using view in a loose, abstract, hand-wavy way, but also in a very specific one. In its most basic sense, view objects mean pretty much anything that can draw itself in a rectangular region of the screen. So a button is a view object. A label is a view object. Most of the things that you can drag out of the object library, these are view objects. If you're looking at an iOS user interface, you might be looking at 10 or 20 or 30 or maybe 100 or more different view objects at the same time. But in this particular usage of it in our code, this reference to view means one view object in particular, and something quite simple and straightforward. This represents a part of our storyboard. When the storyboard was created as part of our project, we got the basic outline of a single screen, but this is not transparent. It contains a view object. It's not a label or a button. There's this large rectangular area with a white background that is configured to fill the entire available screen size. If I open up the document outline, I'll see all these new labels and buttons that I'd added myself, but above that is a view object. If I select that, the entirety of the screen is highlighted. This is a view object that's here to be both a background, so we can set its color, but also as a container, because views can contain other views. So my labels here are all view objects, and they are nested and positioned inside this larger generic view object, this container. And I can see this nesting represented in the document outline. I can even collapse and expand that. So when we see this top-level view in the storyboard, that's what the reference to view means in our view controller. And because views can contain other views, you often need to be able to describe the relationship, and you'll see the term subview is used. Now that is nothing difficult. It doesn't represent anything more complex than this view object, this label, daily tasks, is contained inside this other view object. So it's subview. And as this is our top level view object, all these labels and this button are inside it, they are all its subviews. In code, I could even ask this top-level view object to give me all its subviews, and I would get an array back containing all these labels and this button. And you will often have multiple levels of nested views, views within views, to manage a more complex user interface, to be able to turn entire sections on and off. And the entire stack, your whole set of views containing other view objects all the way down, is referred to as the view hierarchy. Now, we have a very simple view hierarchy here, but it's about to get a little more complex. This one's a bit of an extra credit demo. If you're comfortable with the concept of casting an object from one type to another, I'd suggest you run through this. To prove a point, I'm going to add code to this existing simple behavior, so we don't just change the background color of the top level view, but we also change the text color of any label objects it contains. And I'm going to do that by asking the view object, that top level container, to first just give me all its subviews, however many that is. And I can access the subviews property of our view. This will give me a Swift array. Like everything else in Swift, arrays are strongly typed. These will be arrays of something in particular. So the question is, what's the type? What's it going to give me? I might just want the label objects, but it can't be an array of label objects because we know there's a button object in there as well. Well, if I highlight this subviews part and hit my Option key just to get a bit more information, it's going to tell me that this will return an array of UI view. UI view is the base class of all view objects in iOS. Buttons, labels, sliders, switches, text fields, etc., etc., they all inherit from it. So this is the most generic idea of a view. It's something that can be drawn on an iOS screen. Problem is, UI view as an object is a little too generic, so this won't have the properties that I want, like text color that we can change. So we're going to need to cast these subview objects we've been given into more specific references, into UI label objects. But I only want to cast them if they really are UI label objects, and I know I have at least one button mixed in with them. So let's do this. First, I'm going to add a for-in loop to go around the array that I have. Now, for-in loops just work with Swift arrays, so it'll iterate through however many I have. I then need to check each one, and each time around it'll be called each view to see if this is really a UI label. Now, there are a couple of different ways I could check and cast an object in Swift into something more specific. I'm going to do the longer syntax here because it's also the clearer syntax. So I'll use the is keyword here. If each view is a UI label, then we know it is. What we can then do is create a new reference, and to make that a UI label, I'm going to use the as keyword. Let my label equals each view as UI label. There is a problem here. Swift doesn't like this. As we know, Swift is picky. Now, because we're going from something more generic, we have a reference to a UI view object, and I'm trying to make it something more specific, which is a reference to a UI label object. Swift will require us not to just use this as keyword, but to use as exclamation mark to force the issue. It's similar to force unwrapping an optional. We use that exclamation mark. We could use just the word as if I was trying to cast to a more generic type, but we need the exclamation when I'm forcing to a more specific type. So we're using the is keyword to ask, is it a UI label? If it is, then we're going to convert it to cast it as a UI label and save it in a reference called my label. I'm saying I've checked it, I know this will work, I forcibly downcast it to a UI label reference, and then I will have a more substantial set of properties, the properties found on a UI label object, like text color, and I can change the text color of each label similar to the way that I changed the background. And now when clicking the button, we don't just get the background itself changing, we get all the text colors of the labels as well. In many programming environments, there's often a variety of choices of design patterns, ways to architect and build the different pieces of your application. Whether you're in Java or .NET or Ruby or Python, you might be able to choose from Model View Controller, MVC, or Model View View Model, or Model View Presenter, Model View Adapter, or Presentation Abstract Control, or even none of the above and just wing it and write everything behind a button click. In iOS, there's an assumed usage of MVC, Model View Controller. I say assumed because it would be difficult to avoid MVC even if you wanted to, because the provided pieces, the code that you're given when you make a new project, the objects that Apple provide for you to use, they just kind of assume you're using MVC. They're already built that way. If you're an old hand at MVC, you can skip ahead, but I'm just going to take 2 minutes to make sure we're all on the same page as to what this means here. What MVC asks is that when we're building applications with a user interface, that each object, each part of our application should, at least theoretically, fall cleanly into one of three roles, either a model object, a view object, or a controller object. The model part is your data, whatever that data is. Maybe you write a class to represent a product, or a class to hold individual player data for a fantasy football app, or even a class to represent a task in a Night Porter task list. But the idea with MVC is that you keep it clean. The model objects know nothing about presentation. They're all about data. Now, sure, you might have functionality in your model classes, but that functionality is more about how the data is stored or calculated or retrieved. It's not about presentation. It doesn't describe color or position or whether something should be shown using a label or a text field or a table view or a button. The model is just the data. One of the theoretical goals of a model object is it shouldn't matter if you then took that class and used it on another platform, i.e. the same model code could be used in a Mac desktop application as well as an iOS application because it knows nothing about specific presentation details and it wouldn't contain any references to user interface controls. It doesn't know, it doesn't care. On the flip side are the view objects, the V in MVC. These are about presentation and about interaction. View objects are the things that a user sees and touches. So a label is a view object. A label does contain behavior to be able to draw itself onto the screen and show itself using different fonts and font sizes. It has the ability to have its content changed, but it doesn't store any information. It doesn't calculate anything. It doesn't care if it's being used to display the high score in a game or the title of a movie or the headline in a news application. A button is a view object. It knows how to draw itself on the screen. It can be told what to display as its text, but importantly, it also supports interaction. So there is logic here. There is behavior in view objects. A button knows it can be touched and that its appearance should change when somebody touches it, but it doesn't actually do anything in particular. It is generic. A button will allow us to add our own functionality to that. But if the model objects include no functionality about how they're presented, and the view objects include no functionality about what data they show, how do we connect one to the other? And that, of course, is the role of the controller. So the model objects don't talk directly to the view objects don't talk directly to the model objects, but the controller talks to everybody. Everything goes through the controller. It's responsible for providing the view objects with data in the first place, and if the view objects are updated and changed, how that data might be passed back over into the model. In a course like this, we're not building any substantial architecture. We won't be doing many dedicated model classes. What it effectively means is the majority of the code we'll write here, most of our logic, will be controller code. Now, MVC does not mean you have one model, one view, and one controller. It's not this 1-1-1 ratio here. It's much more flexible than that. You might have one controller in the middle that's talking to 20 view objects on one side and 2 models on the other. But there is an important way that these collections of objects will start to get grouped together in iOS. When we made that first project in Xcode, that first single view application, we got our storyboard, which begins with just this one section, what's called a scene, which at this point we can think of as the first screen of our application. And we know we can add multiple view objects onto this one scene. We also know that this section of the storyboard is connected to one Viewcontroller.swift file. It's our first controller class. So this one piece of controller code is going to manage all of the view objects that we add to this part of our application. And the combination of the two, This part of the storyboard, together with our class, is called a Viewcontroller. And you see the term Viewcontroller everywhere. You see it in the code, you see it in the storyboard. And that's because a Viewcontroller is the fundamental building block of iOS apps. You'll always have at least one Viewcontroller, and as you build bigger apps, and we'll see this shortly, you'll add more. When you create a new project in Xcode, the default main.storyboard comes with a predefined connection to the Viewcontroller Swift code file. These two things are already connected. But as we add additional elements like new controls to the storyboard, we will need to define any additional connections between our user interface and our code. And we'll do this by creating actions and outlets. Now, a quick sidebar, depending on your programming background, you might assume that when you start dragging and dropping controls into a storyboard that they're going to be exposed in your code. That if you drag on 3 labels, you're just expecting 3 objects in your Swift called label 1, label 2, label 3. That's not how it works here. Unlike some languages and technologies, when you drag UI elements into a storyboard file, it does not generate Swift behind the scenes. A storyboard is not procedural code. It's actually an XML file. I can even view this by opening it as source code. I'll see it's just a bunch of XML. You're not intended to edit this, but it's worth showing every now and then. The storyboard is really a list that describes all these UI objects you've dragged on, how you've configured their properties and settings, but the same way that we had to define, say, the contents of a label, or if we wanted to define a different font style, or the position of a user interface element like a button, we also have to define whether these are connected to our code and if they need to be explicitly connected at all, because a lot of the time they don't. Take these labels. These are positioned, they've been given explicit values, and unless I need to write code to change them, I don't need them showing up in my code. I don't need to see any kind of reference to these labels right now in my Swift file. However, that wasn't true with the button. The button did need to be connected. I wanted to be able to tap the button and call some code, which is what we're doing with this action here. And that's an action. When you want a user interface element to cause something to happen, you want it to cause a method to be executed in the code, you're going to create an action. And an outlet is when you want to go from the code to the user interface element. Maybe you want to write code to change the contents of a label, or you want to write code to grab the contents of a text field, or enable or disable a switch. And sometimes the same control can be connected as both an action and an outlet. Say a button needs to be defined as an action so it can cause something to happen, but it also needs to be defined as an outlet so that the code itself can change the button text or toggle that button between enabled or disabled. So an action will be a Swift method, an outlet will be a Swift property. And in Xcode, you'll define actions and outlets by shifting into the assistant mode, this side-by-side mode here, and control dragging from your storyboard into your corresponding code file. I'm going to do a couple of examples of these, and I'll also show how people commonly mess this up and how to fix it. Rather than mess up our little app, I'll demo this with a new single view application in Xcode. I just created a new project, dragged on a label and a button. When I click the button, I want to set the text to the label. So this button needs to be an action. It needs to cause something to happen. And the label needs to be an outlet because I want to change it from Swift. So I'll minimize my left and right panels and switch into assistant mode using the second button here. I should see the Viewcontroller code on the right-hand side. I'll create the outlet for the label first, so hit the control key, click the label, drag over. We're waiting to see that pop up to insert an outlet or outlet collection. It won't let me drop it somewhere that doesn't make sense. This needs to be within the body of the class. I'll put it in just right at the top here. This will be an outlet, and I'll call it basic label. Verify that it is a type of UI label. This will be strongly typed, and click connect. And we get our outlet defined. Moving on to the action. Hit control, click the button, drag over, let go. This time it will not be an outlet. We always want to be careful with this drop down here because it's very easy to select the wrong thing. I'll change it to action, give the action a name. It'll be change label because this will create a new method for us, and hit connect. we get that IB action new method. Inside there, I can talk to the label and just change its text property to some exciting new value. Let's go ahead and run this. I'll just verify what simulator it's going to use. I'll just pick something smaller like the iPhone 5 and hit Command R. Once again, because I have a very small screen size, I'm going to go to the simulator's window menu and change the scale down to 50%. So I see the button, and if I hit change, I can change the value. I do see that it's blowing out the contents of the label. We're getting the ellipsis because the label is not quite big enough to fit its new contents. Again, a little later on, we're going to see how we deal with that kind of issue. Back into the code. So our label, our outlet, has been defined as a property. It is a var basic label, and our action is a method, a Swift method here with the func keyword. You'll notice that we have these attributes on this @IB outlet and @IB action. This is a marker. It's an indicator that these pieces are connecting in some way to a user interface. IB action and IB outlet are terms that predate Swift by many years. They're from when we used to use a separate program called Interface Builder, IB, to do our user interface. And the important thing is, if I was looking at these files later, say I was just looking at the storyboard, how would I know, how would I realize when there's a connection already defined? If I'm looking in the code, I can see the words IB action and IB outlet, but there are other clues. So if I'm in the standard editor, one method I can do is I can right-click any of the elements. I'll get this pop-up window here. If this wasn't connected to anything, I would see a whole bunch of empty circles here, but I see one that's not empty, and it's telling me that the touch up inside event of the button, that's what happens when you touch it and then let go, is looking at the view controller and calling the change label method. So I can see from this perspective that as far as the storyboard is concerned, there is a connection. Same thing with the label. If I either right click or control click, I will see that there's an outlet listed here that it's linking to basic label in the view controller code. There is another way to see this. If I have the utilities panel open and take a look at the very last inspector, you can see the same information when I'm clicking around that this is actually connecting to some piece of the code. Now, from the other perspective, if I wanted to look at the code itself, I'll flick over into my viewcontroller.swift file. And what I see is these dots here in the gutter. These are kind of a clue that this is connected to something. If I click them, it says this is linking to main storyboard, something called basic label, and this is linking to main storyboard, a button that says change on it. Again, if we have the assistant mode open, you see a little more. I'll switch over to my main.storyboard. And then when I'm mousing over these, you'll actually see them highlight where the links are between the two. So when you make a connection, it is a handshake. It's two changes that are made. Part of the connection is defined in the storyboard. Part of the connection is defined in the code. And this leads us to the most common way that people mess this up when they're making connections. They do something like this. They're working on the storyboard and they switch to the object library and they grab a button and drag it on. We'll call this the second button. Then they switch over into assistant mode. They hit the control key. They click and drag and they let go, and they're thinking that they want to create an action. They're going to make something or do something, and they hit connect, but they accidentally do it with this still set to outlet. Accidentally created one instead of an action. Now this happens. It's an easy mistake to make, and this itself is not the problem. The problem is when someone tries to fix this by just deleting the offending code in the code file, because that now only removed one side of this. The button in the storyboard still thinks it's an outlet. And if I go ahead and run this application and load it up on the simulator, we actually crash. We're going to get an error, a runtime error. And the only way to fix this right now is to go into the storyboard and check each element and see if it thinks it's connected to something, but it actually isn't, which is the case here. So with the storyboard selected, what I can do is use that right click, verify that this has this empty connection to do something in the view controller, but that was deleted. So I can delete it from here. And now we should be able to run this code again. At least we won't get a runtime error. This is now deleted on both sides of the equation. So there's no code referring to it. There's also no connection on the button. So I could recreate it now and create the actual action that I wanted to do. Back to the Night Porter app, and our friend has found out there are several more tasks than she originally thought. So I've gone ahead and added a few more labels at the bottom, but here's the problem. If I run this on an iPhone 5 simulator, there's now more content that will actually fit properly. We're not just losing a little bit from the sides, we're also losing a lot from the bottom. We see a bit of this button, but it's pretty much missing. We have too much content, and particularly if we decide to rotate. In the simulator, I'll use the hardware menu to rotate left. It does shift into landscape mode, and we do get our full labels here, but we lose everything below this label now because there's no scrolling behavior. Again, there's a couple of different ways we could approach this and fix it. One would be a smaller font. Another would be just moving the labels closer together. Another could be different screens in the application. But what I'm going to do right now is make use of the opportunity that we just explored the fact that views can contain other views. Right now, all of our labels are nested inside our top level view object. If I open up the Viewcontroller document outline, I see that I have the view, which is the entire container, and everything is nested inside of that. I'm going to use the document outline to select all of these, all the subviews. I don't want to select the view itself, just all the labels and buttons. With those selected, up to the editor menu, come down to the embed in option and select scroll view. Now notice now in the document outline what we see is a view contains a nested scroll view, and the scroll view itself, which is also a container, contains our button and all our other labels. So scroll view is another container, but as the name might suggest, it adds the ability to support scrolling content when there's more than will actually fit on screen. Now, there's a good chance that when we do this kind of shift, when we take a whole bunch of controls and put them inside something else, we might see some kind of issue in our storyboard, which is going to be the little red lines here saying something's not quite right about the way we have things positioned here. And we're going to get into this whole idea of positioning elements a lot more later on. For now, I'm going to go up to the editor menu, down to Resolve Auto Layout Issues, and hit Reset to Suggested Constraints. Then I'll hit Command R and we'll test this again. It loads up, and now I have the ability to scroll. I even see on the right hand side the scroll bar indicator. We can also shift to landscape mode, and we have the ability to scroll all the content there as well. Now, one thing I am going to notice is if I hit the dark mode button, it's going to change the background, but it's not changing the text of the individual labels to the lighter color. And the reason for that is that the code that I wrote in there looked inside view for all its subviews. And right now, view only has one, which is scroll view. Everything else is now nested one level deep inside of that. So if I wanted to fix that code, I'm going to have to go a little deeper inside. It's not now in the subviews of the view. It's in the subviews of the subview of the view. It's one of the things you have to bear in mind when you're doing all this nesting. Now, one thing I do want to point out, I'm going to go ahead and run this again, is even though this isn't a complicated view hierarchy, there is something worth seeing. When the app is running, I'm going to just flick back into Xcode, and down here we'll see this bar at the bottom. You only see this when the app is running and debugging. There's an option here, this button called Debug View Hierarchy. If I click that, what I'm going to do is get a 3D representation of my app and how the different view objects are rendered. It doesn't look like 3D right now, but if I click a blank area and shift it, we can actually shift it up and down. I can use the slider on the left to separate the pieces out. It's going to show me the levels of the view hierarchy here. If I select one particular view object, say this Check All Doors label, I see it in the jump bar at the top. It's showing me exactly how this is nested. It's a label nested inside a scroll view, nested inside a view, nested inside a window. From this point onwards, we're now running into the standard app architecture provided by Apple. So this can be a very useful way to diagnose user interfaces when they don't seem to be displaying what you think they should be. But we're now really hitting the boundaries of what we'd actually be doing realistically with these individual labels. So in the next module, we're going to step it up into using data-driven controls. A single view application is a microcosm of the entire world of iOS development. The ideas we need here are exactly what we need when we get to more complex applications later on. We saw the term UI kit, covered why the letters UI are so common here, and how to get help within Xcode itself. Then we explored that concept of a view, views containing views, or rather, views containing subviews, and the whole idea of a view hierarchy. By understanding view hierarchies in iOS, it makes it easy to do things like iterate over all labels in a complex screen full of content and change them all, but without us having to provide instance names or object IDs or defining outlets for any of them. We saw an example of checking data types and using forced downcasting in Swift using the is and as keywords, and covered the importance of the model Viewcontroller pattern in iOS, that it would be hard to avoid even if you tried to. And that when you make connections between your user interface view objects and your controller code, your Viewcontroller, you do this by defining actions and outlets. And during the demo, as we got back to our Night Porter app, we added additional content. We saw how to embed that content in a scrollable view so we can fit more than would show on one screen. But now we're going to move away from basic labels and buttons and start exploring more complex controls.